Okay, so today we're going to be talking about hydrocarbon derivatives, alcohols, and alkyl halides. This is, of course, about the middle of our organic compounds unit in Chemistry 30. Here we go. So we're moving on to hydrocarbon derivatives today. These are a separate category of organic compounds, different from the hydrocarbons we've seen so far in this course. The two types of hydrocarbon derivatives we'll investigate today are alcohols and alkyl halides. We'll look at how to name and draw both of them. Now, despite being different from the other hydrocarbons we've learned about, you'll find that the conventions we use to name and draw these are actually quite similar. So in other words, a lot of the stuff that we've learned about naming, let's say, alkanes or alkenes or alkynes, or even the cycloalkanes or cycloalkenes or cycloalkynes, a lot of those old terminology and old rules still come back. So a lot of this should feel familiar. It's going to be a pretty busy one today. We'll see how long this goes, but here we go. So this is not in our notes quite yet. This was from earlier on in the unit. Just a reminder once more about what we're kind of looking at in terms of organic compounds. As you can see kind of from this flow chart here, organic compounds can be either hydrocarbons or hydrocarbon derivatives. Prior to today, we've only been talking about hydrocarbons, especially the aliphatic hydrocarbons like alkanes, alkenes, and alkynes. But we did also start talking about aromatic hydrocarbons as well. The focus for today is to get away from those and talk about hydrocarbon derivatives. These, again, are going to be pretty similar to the ones we've talked about with hydrocarbons, but there are some notable exceptions. Anyway, we'll dive into it. So this is in our notes. Hydrocarbon derivatives. Organic chemists go beyond the typical hydrocarbon and classify chemical compounds according to their functional group. A functional group is a special arrangement of atoms that is mainly responsible for the chemical behavior of a molecule. These groups can also determine some of the physical properties of the substance. We've already looked at some different functional groups. So when we talk about alkanes or alkenes or alkynes, those are different functional groups. Today, we're going to be focusing in on alcohols as well as alkyl halides, which are two separate functional groups as well. So alcohols, first and foremost, again, this is in our notes. There's some blanks to fill in here. Alcohols contain an OH functional group, which is commonly called a hydroxyl group. They have the general form ROH, which is kind of a funny way of doing this. This R, if you can believe it, literally stands, and you write this in your notes if you want, literally stands for rest of the molecule. So in other words, you have the rest of your molecule, and then there's an OH attached to the end. As far as we're concerned, the rest of the molecule is going to look a lot like the hydrocarbons we've been looking at. Just below here, I've thrown in a picture. I don't think this is in your notes, but methanol, for example, it looks like a hydrocarbon over here on the left side, but then we have an OH attached to it on the right side here. Ethanol, same kind of thing. There's an OH attached to the right side. Propanol, once again, OH attached to the other side there as well. Just judging by these and looking at like the prefix part of each of these words, you can probably already start to guess what some of the rules for naming this is. But the general idea that I just need you to get is that there's a hydroxyl group added to the end. Now, this is where I need to clarify. A hydroxyl group, an OH, is not to be confused with something that looks almost the exact same. It's not to be confused with a hydroxide. That was an OH negative ion. Now, we saw that a lot back in Chemistry 20. A hydroxide ion was actually one of the main things we look for when we were dealing with bases. There's a bit of a difference here, right? So the difference on this one is that this is attached to the rest of a hydrocarbon. That, of course, is a very blatant difference. It's also the fact that this right here, this OH negative, this hydroxide, I'll even write that out so you see it's a difference. A hydroxide is also an ion, so it's actually got a charge component to this. Whereas the OH hydroxyl group is actually a covalent, or in other words, molecular bond added on to the side of this hydrocarbon here. It might seem like a bit of a nitpicky kind of differentiation that we're making here, but it is important nevertheless. I don't want you getting confused that a hydroxyl group is the same thing as a hydroxide. Very similar, but not the same, right? So for now, I just need you to understand that alcohols have the general form ROH, where that rest of the molecule, that R, is more or less basically just the hydrocarbons we've been looking at. Anyway, enough of that. Moving on. Naming and drawing alcohols. This, of course, is in your notes as well. I'll just run through the steps to this. It's very similar to the stuff that we've been doing before. Start by identifying the root. So in other words, locate the longest chain that includes a hydroxyl group. Name the parent alkane. Now, one thing I want to say is the terminology they used here where it says includes a hydroxyl group, you don't count that towards Like you're naming the parent alkane, right? So in other words, if there were two carbons and then the hydroxyl, it's still just like an ethane, right? It's not going to be it's not going to upgrade to three, like to propane or anything. It's going to stay as an ethane because you're only counting the carbon atoms themselves. Anyway, it is what it is. Anyway, so the suffix now, identify the suffix. The suffix will always end with ol, right? So all, right? That's how we can differentiate what an alcohol is. The position of the hydroxyl is indicated by a number in front of the ol, right? We've done this before with alkenes and alkynes. Remember, we're looking for the double bond or the triple bonds location. Very similar to this as well. So the position of the hydroxyl is indicated by that. Now, it's important to also mention the numbering of the carbon chain begins with the carbon atom at the end of the chain nearest to that hydroxyl group. So very much like alkenes and alkynes, where we actually had to go closer to the double or triple bond. Very, very similar idea here. So start at the end closest to that hydroxyl group and then go in order. Number the carbon atoms in order. Now, if there's more than one hydroxyl group, because that is actually possible, you could have more than one OH stemming off of this, you need to use a prefix like di or tri or tetra to indicate the number of hydroxyl groups. So if there's three OHs branching off of this thing, you have to call it tri-all at the very end. Tri-all at the end, right? A number for each hydroxyl is placed at the beginning of the suffix. So you'd actually have to, like say, let's say it was at position 3, 4, and 5 for this one, because there's three of them here. You'd have to say 3, 4, 5, triol, right? There's actually one of these in the Your Turn section that we're going to get to in just a second. So just a bit of a heads up, you're going to see one of those in the Your Turn section, which might not actually be totally fair. Maybe we should have done that one as a practicing together. But anyway, I'm ranting here. So again, a number for each hydroxyl is placed at the beginning of the suffix. Now, if the suffix begins with a vowel, this is a really weird term, you got to drop the E on the end of the parent alkane. Um, Generally speaking, off the top of my head, I think it only will really begin with a vowel if there was only one hydroxyl group because then it ends with all. Uh, there might be others actually now that I'm thinking about it, but like I guess with like if there was eight of them, I guess that'd be like octal, whatever. It is what it is. But anyway, you drop the E on the end of the parent alkane if it begins with a vowel. But if the suffix begins with a consonant, so not a vowel, you don't drop the E. Kind of a silly rule, but that's just how they do it, right? And then lastly, of course, identify your prefix, name a number of any alkyl side groups on the main chain. That's the same as it was when we looked at branched alkanes, alkenes, and alkynes. So you got to name any branches that come off of this thing too. Anyway, that was a lot of rambling. These are often way easier to see with an example, as always. So we'll do these two together. So two different examples here. It's not like this is the name of the one above, not even close. We'll start with this top one here. We gave you a structural diagram. We want to come up with a name for this. So one of the most important things, of course, is identify where your hydroxyl is. It's pretty easy to spot. The hydroxyl is right over here. There's our OH. Now, numbering has to begin at the carbon closest to that. So that's pretty easy as well. Numbering is going to start right here. So that's going to be 1. But it's also important to tell what's our main chain. If you look at this, you might look like at first glance like the main chain was 1, 2, 3, and then 4 right here on the left. But actually notice we branch upwards to make that 4, 5, and 6. I think it's been a little while since we've seen something like this where it kind of, tricks you into thinking that it's going one way or another. Because at first glance, you might have thought these three coming off the top were like a propyl coming up off the top, but it's not actually. You have to look for the longest continuous chain. Even if it bends and spirals around or whatever, it still counts as the longest main chain. So this long main chain here is going to be a hexane, right? Because there's 1, 2, 3, 4, 5, 6. That's going to be a hexane. But the funny thing is we only have one OH, which means this thing is going to end with OL. It's not going to be diol or triol or tetraol. It's just going to be a single OL, which again, that begins with a vowel. So we actually have to chop the E off that hexane. So it's just going to be hexan, and then we'll build the rest from there. So it looks like we understand it's going to be a hexan all, but we also need to notice that there's one branch coming off this thing, right? It's coming off at location 3. Since there's only one carbon in it, that's going to be a methyl coming off there. So just as before, we got to tie it all together. And I know it's a lot, but we always start with all our branches and stuff and what positions they're branching off at. So that's going to be a 3-methyl. That was the only branch. So now we can actually get to like the parent chain here, like the main chain. That's going to be a hexane. There's not going to be an E on the end. It's not going to be hexane because it's going to be end with all. We should also throw a number in for where the location of that OH is. It's branching off of position 1. So we're going to say it's hexane 1 all. So 3-methyl hexane 1 all. That would be the name of that first one right there. For the second question, we got propane 2 all. Propane 2 all. So this time I gave you a name. I would assume it wants us to draw the diagram for this thing. Well, propane 2 all, first of all, we can see since it's propane, that means we're going to have 3 carbons in a row. Maybe I'll just start with that, actually. I'll start by drawing my 3 carbons. Give it a little bit of space. Carbon, 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 right there. Now we also see it says 2 all. 2 all, that means at position 2, we got an OH coming off this here. So I'll just branch off this one right here in the middle, position 2, and I'll just stick an OH on there. The last thing I always do is I fill out all my H's and stuff. So since there's a C on this end here, maybe I should draw my bonds too. I guess that'd be pretty smart. Since there's a C right here, only one bond on it, that tells me I need CH3 because it has to have 4 bonds all around it. This carbon here in the middle, you know what, I'm actually going to move this over just so I have a little bit more room. This carbon here in the middle, it's got 3 bonds around it, which means it can still take 1 H because that fills it up to 1, 2, 3, 4 things around it. And then this carbon on the right, it only has one thing attached to it right now, so it needs a CH3 as well. That's about it, right? So that would be our structural diagram or condensed structural diagram for propane 2 all. If you wanted to be really crazy and want to do one of those like line diagrams, same kind of idea. Draw a line and make it bend anytime there's a new C. So one, I guess 1, 2, 3. These are a little confusing because there's a carbon right here, carbon at the bend, and then a carbon down there. And then I guess we'd have an OH coming off the top. That would be our that'd be our line diagram, and that's about all there is to that. But truth be told, on this question, probably prefer this. It didn't tell us what to do, so why not? Anyway, there's 2 more questions. They're both your turn kind of questions. I want you to try them, and I also want just to remind you, I gave a bit of a tip that for one of these, hint, hint, wink, wink, nudge, nudge, for one of these, you're going to want to use a prefix in front of the all on the end. Hopefully you can tell which one. If you're watching this as a video, you might want to pause the video right here, and I'll go over these in just a second. Try your best on these ones. So you can pause the video, and I'll go over them. All right, so now time to go over these ones. That first one right there, I'm going to stick pretty simple here. Every single branch on this thing is a hydroxyl. There's no like methyl or ethyl or propyl kind of branches on this. So the only branches I really care about are these, these alcohols coming off, or the hydroxyls, I really should say, coming off here. Because of that, we can just start right up with our main chain. Since the main chain is 3 carbons in a row, I know that's propane, right? Now, there's 3 hydroxyls coming off here, so I also know that this is going to end in triol. And notice that because there's a consonant, a T at the front of that, we're not going to drop the E off of our main chain. So instead of calling this propane something triol, we're going to keep it as propane, full propane. We're not going to drop the E off the end. So let me show you what I mean. There's no branches on this other than the hydroxyl, so I can start with that main chain. It's propane dash. We have these hydroxyls coming off at position 1, 2, and 3, so I should list that. 1, 2, 3, and then triol. Propane 1, 2, 3, triol. That would be the name of that thing right there. So again, the reason that that worked like that is because there was no branches, so we don't have a methyl or an ethyl out front. And because there's 3 of this, it's going to be triol, which begins with a consonant, so we don't chop the E off the propane there at the front. Again, really functionally, at least as far as I can remember, we only really chop the E off the front if there was only one hydroxyl coming off of it, because that's one of the only ones that begin with a vowel, but is what it is, right? Next one, we gave you a name. That means we obviously want a diagram to go with this. Diagram for this one's going to be pretty huge, to be honest, because if you look at the parent, it's got octane, excuse me, octane as its parent. Octane, of course, means there's going to be 8 carbons in a row. So buckle up here. Let's start with that. 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row right there. At 3, position 3, there's going to be an ethyl. At position 4, there's going to be a methyl. And the location of our alcohol here, or our hydroxyl, is going to be at position 1. So it's a matter of perspective how we want to draw this. Most people probably would think drawing it from left to right, saying this is one, two, three, and so on. So that would mean our OH is going to have to go here on the left. But if you really wanted to, you could put the OH on the right. And to be honest, I think oftentimes I usually see OHs stuck on the right. Uh, I have to admit, I don't know if there's a right or wrong way of doing that, but you know what? I'll follow with that. So as backwards as it seems, if you do it the other way, it'll be fine. I'm going to say that this is carbon 1 right over here, and then 2, and so on. Let me just erase that because I don't want those in there. Anyway, long story short, that means I'm going to stick my OH, because that's where the all comes in, at 1. So I'll put an OH over here. We have an ethyl at position 3, so 1, 2, 3. There's going to be an ethyl. Remember, an ethyl means 2 carbons, so we'll do a carbon. And then, you know what, just go up another carbon. Why not? You could bend it, whatever you want. And then at position 4, we have a methyl. Well, that's just 1 carbon, so I'll just put 1 carbon there. And I think now we should just fill out all of our bonds, right? So I put a bond here, and here. Fill them all in. Leave room for the H's that we're going to have to write in here. In terms of our H's, this time I'm going to go from left to right because why not? This C only has 1 bond, so I need CH3. This C has 2 bonds, so I need CH2. Same with this one, CH2. Same with this one, CH2. This one right here has 3 bonds around it, so it only has room for 1 hydrogen. This one going up has room for 3 hydrogens because there's only 1 bond. This one right here has 1, 2, 3 things around it, so just 1 hydrogen, and then CH2, and then CH3 going up. This one right here has 2 bonds around it, so I need CH2, another CH2 right here, and that actually wraps up the entire thing. So as crazy as that might look, that would actually be our 3-ethyl-4-methyl octan 1-ol right there. So pretty crazy, but is what is. Anyway, this brings us to practice. This is not the end of the lesson. I want you to practice the ones that are titled Practicing Naming and Drawing Alcohols. That again is in your notes booklet. Shouldn't take too terribly long to work on these. I'll give you maybe 10 or 15 minutes or so. So you want to pause the video here, and when we feel like we're ready to move on, we can unpause it and go from there. So hopefully you were able to make good progress on those. We're going to move on to the next part of the lesson here. We're going to be talking about something called alkyl halides, which is a different kind of hydrocarbon derivative. So alkyl halides, and this is in your notes, by the way, of course, it'll be on that next page. Alkyl halides are hydrocarbons that contain at least 1 halogen atom. If you forgot what a halogen is, just because it's probably been a little while since we've talked about that, a halogen is anything on the periodic table in group, also known as a column, group 17. So group 17, that would include things like chlorine or bromine or iodine. Take a look at a periodic table. You can see them all there. Anything in that 17th column, group 17, that's a halogen. Now, alkyl halides, they're not found in living systems. They're artificial in nature. And they have the general form Rx, which I think is such a silly general form because, again, R just stands for rest of the molecule. And X is, in this case, just your halogen. So if it was chlorine, then that would be chlorine there. If it was bromine, it'd be bromine there, whatever, right? Kind of a silly general form, but I found this picture that kind of shows 2 relatively simple alkyl halides. There's chloromethane, right? So it's a chlorine coming off of what looks like otherwise a methane. And then bromoethane, bromoethane, so it's bromine. That's why there's bromo there, coming off of what looks like an ethane, you know, 2 carbons and all that. That's kind of the idea here. So these are alkyl halides. And that is what it is, right? So anyway, jumping right into naming them, very similar to the other stuff, guys. Let's be honest here. Locate the longest chain that includes the halogen atoms. Name the parent alkane. So again, once just like we did with the alcohols just now, don't actually count the halogen as one of them. You only count the carbons, but you have to link it on to the main chain, right? That's the idea. Then identify the prefix. Number the parent carbon chain starting at the end nearest the halogen atoms. So just like before as well with alcohols, you got to start numbering closest to that halogen. If the compound is a cycloalkane, numbering starts at the carbon atom bonded to the halogen atom. So if you're numbering them in that, circular kind of structure as well, you start at the carbon atom bonded to the halogen, right? Then name and number all the alkyl side groups on the main chain. So if any branches come off, give them names and numbers. Insert the numbers of the carbon atoms bonded to the halogens. Use prefixes that identify the specific halogen or halogens, so chloro or fluoro, bromo, iodo. That's a weird one to say, iodo, right? That'd be for iodine. If there are two or more of the same type of halogen, use a prefix to indicate the number. So if you had like 3 chlorines, you got to call it trichloro. Or if you had 2 fluorines, you got to call them difluoro. You got to put a prefix on those, right? And then if there are more than one type of halogen present, write them alphabetically. Maybe I'll underline that. So that's kind of like what we did with our alkyl groups, like the branches that came off. You got to write them alphabetically. It's entirely possible that we might have one of these that has a chlorine and a bromine. Well, bromine starts with a B. That comes before letter C in the alphabet, so you got to put the bromo first, right? Now, any prefixes, di or tri, they're not considered when alphabetizing the terms, right? So if you have a bromo and a chloro, but then you have 3 bromines, so that would make it tribromo, you can't just go, oh, well, now T is later in the alphabet than C. No, 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 no. It doesn't work that way. You have to just go by like the actual halogen name itself. That's what you're going through here, okay? Anyway, let's get some practice on these ones. It's again not as crazy as it seems once you see some examples. I find that this is the best way of learning these. So this first example, we got quite the chain there. It's pretty clear and set that we've got 6 in the chain there. So since there's 6 in that chain, that's going to be a hexane. But also notice we have 2 bromines coming off this thing, and we have a chlorine coming off this thing. Now the idea is we have to start our numbering at like the closest one to the start, right? If I started on the left side, my bromine would be at position 3. But if I start on the right side, this bromine here is at position 2. That's probably a better place to start. So to number this, I'd say 1, 2, 3, 4, 5, 6, starting from the right. So to name this thing, we have bromine and chlorine. Like I said a moment ago, bromine happens earlier in the alphabet than chlorine. So we're going to name those ones first. Watch how simple this one is. It's just going to be a matter of saying, look at their positions, 2 and 4. So I got to go 2, 4. There's 2 bromines here. So I'm going to say di, bromo. And then we're done with our bromines here, but we can't forget about this chlorine at position 3. So then we just move on. Dash 3 dash chloro. So look, we have our 2, 4 bromo, and now 3 chloro. And that's all the branches on this thing. So let's just finish it up with its normal alkane name, which in this case, because there's 6, it would be hexane. So 2,4 dibromo, 3-chlorohexane. Quite a long word, but is what it is. Let's try this next one. Bromoethane. Bromoethane. This time, because it gave us a name, it probably wants us to do the diagram of this thing. I would start by drawing my ethane, right? I'll fill out all my hydrogens and stuff later. But ethane, pretty simple. It's just 2 carbons. So carbon here, carbon there. Now it doesn't tell us which one the bromine, I guess, would be attached to, but that's only because there's only 2 of them here, right? I could put bromine on the left one or on the right one. Either way, it's just starting at the start, right? It is what it is. So tell you what, I'll just put it on the one on the left here. So I'll put a bromine right here. Everything else, just fill out the rest of your hydrogens. I guess I should put a link between those 2 carbons. So this one here is going to be CH2 because there was already 2 bonds. This one on the right, though, is going to be CH3. And that's about all there is to this. You could have put the bromine on the right. Really doesn't make a difference as far as I'm concerned. There's our diagram. Not a big deal. Okay, 2 more examples. They're both your turn ones. You guys know the drill on this one. You're going to want to pause the video here and give these a shot. Notice that first one is a cycloalkane. The rules still work the exact same. Remember, start the numbering to get the lowest numbers possible at one of those halogens, and ideally it'd be at the one that you'd be listing alphabetically first. Anyway, give those a try. Pause the video here if you haven't already, and good luck. All right, now I'm going to go over them. So to go over this first one here, I see a bromine up on the top, a bromine over here. This CH3 is not a halogen. That's just straight up like an alkyl group, right? Like a methyl or an ethyl or a propyl. Well, I mean, it's a methyl clearly because there's only 1 carbon. So that's not my main priority. The main priority, as soon as we have an alkyl halide here, so in other words, as soon as we have these halogens, we should number based on the location of those. If I started at this kind of diagonal bromine right here, it'd be like 1 and then 2, 3 at the next one, but then 4, 5, 6 at this methyl. That's not ideal. So I think the best one would be to start way up here at the top and say this is 1, and then 2, 3, 4, and I guess 5, 6 just for good measure. That's going to give us our lowest numbers while also making sure that we hit that halogen at our first number there, right? Start by naming your halogen stuff first. So in this case, because it's bromo versus methyl, we're going to say 1, 3 dash, and since there's two bromines, we have to say dibromo. Then we got to name that yeah, the alkyl group that comes off this thing. So because at number 4 there's a methyl, we have to say 4 dash methyl, and then this is a cycloalkane, so we can't just call this hexane because hexane would be in a straight line. This has to be cyclohexane. Wow. So that was quite something there. That was really combining like a ton of the different things that we've covered in this course so far. But 1,3-dibromo, 4-methyl cyclohexane. That would be the name of that guy. This last one here, obviously we want a diagram of this one. Once again, it's going to be a pretty big one. We had a big one earlier today too. 2,3-triiodo 3-methyl heptane. Holy smokes. Good news is this one is not a cyclic because I don't see cycloheptane in here. That would have been just one added thing to make our lives miserable on this question. So it's going to be in a straight line. That's what I'm getting at here. So heptane means there's going to be 7 carbons. So let's do 1, 2, 3, 4, 5, 6, 7. So 2, 3, 4 triiodo. So there's going to be 3 iodines on this thing at position 2, 3, and 4. Tell you what, let's just keep it easy here. I'm going to put an iodine right there, an iodine right there at 3, another iodine there at 4. But then it says a methyl is also at 3. Let's put the methyl going down this way. Methyl would be a C down this way. And then link all the rest of these as we normally would. So dash, dash, all the way across. And to finish it up, we have to, of course, just fill out all of our hydrogens that would make this up. Remember, we want to fill all the bonds on our carbons here. So this one's going to need a CH3. This one already has 3 bonds, so it's going to be an H. This one right here has 4 bonds all around it, so joke's on us, there's not going to be an H on this thing because it's already got 4 things around it. It wants 4, so it's already got it. This one going down, though, needs a CH3. This one has 3 things around it, so it just needs 1 H to bring it up to 4. This has 2 things, so it's going to need an H2. This also has 2 things, H2. This one has 1 thing, so it needs CH3. Woo! So there it is. That is all said and good. And that takes us to 2,3,4 triiodo 3-methyl heptane. Wow. So I knew it was going to be a long one today. Hopefully we were able to clear it. If we don't get to all these questions, that's okay. But practicing naming and drawing alkyl halides, please get a good start at those questions because this stuff obviously needs some practice. And as always, best of luck.